Greetings, this is my week 7 submission. I'm going to start with a discussion of the doorknob problem. We know a doorknob is a simple machine, also known as a wheel and axle. So I developed my own simple machine which included a screwdriver, marker, and some tape. I lined the screwdriver so it went over the center hole on this doorknob and taped it there and taped it to the marker, and I was able to create my X and Y axes from that center hole in the doorknob. And as I twisted it, you can see it's a little shaky, but it did work. And using my paper protractor, because I'm probably the last remaining mathematics teacher in the civilized world who doesn't have a real protractor, which I apologize for, I was able to calculate that my doorknob needs to be twisted 48 degrees before it can be opened. I then decided to tackle 25.1, and we are given this initial shape. Coming into this, students should have an understanding of, and I'm getting ahead of myself with semicircles, but squares, calculating the area of squares, rectangles, triangles, and semicircles, something we'll see in the following two problems. If they don't have a good command of how we calculate area of these four shapes, or why we calculate them in this using these formulas, then we should really return to how and why, and before moving on to figures or shapes like this. Now, the way I see it, when I look at this shape, I see a rectangle, two triangles, and a square. But someone else could certainly see one rectangle and two triangles. Either way, when you sum the area of either the three or two shapes, you should come to 15 centimeters squared. And I think, and either way is fine, and you're going to get the same answer. But for me, I see a rectangle, two triangles, and a square. And using my previous knowledge of area for these three images, I was able to calculate the total, which is in the top right. I went and for me, this shape isn't all that complicated. This, on the other hand, involves four semicircles, which we're told that they are all congruent, and a square. Now, the square will be is easy to calculate, but students may know that the area of a circle is pi r squared, and they might know why we do it that way. But it might not be immediately obvious that the area of a semicircle is simply half the measure or the area of a whole circle. And that is something that you can either have a discussion about or have students critically think amongst themselves or in small groups to determine that formula. But again, if you know the formula and students have a strong foundation in how we calculate these things, and are comfortable visualizing or deconstructing the image, calculating the total area of this shape shouldn't be very difficult. In this final shape, which is not nearly as difficult as the previous one, in my opinion, I see a rectangle and I see a semicircle. And looking at this, we use our same knowledge of the area of a semicircle and the area of a rectangle. But I do concede that because none of this in the middle was given to the student, they may not realize that where we are told that the side length is 2 inches, we can draw this auxiliary line to create these two shapes to better allow us to calculate the sum of this entire shape. So that might be something that might trip them up. But again, once you deconstruct the image and you determine how you want to attack it, knowing the area of a semicircle is 1/2 pi r squared, and knowing the area of a rectangle is width times length, and then summing those two numbers to give you the total area of the shape, again, shouldn't be all that difficult for students to do if they have a strong foundation in these formulas. And that's all I have, so thank you for your time.